I'm talking to myself. Good morning, everyone. Apologies for the delay. I hope you are able to hear me. If you don't hear me and it cuts off, let me know so I can repeat whatever the statement I was making, because I am load shedding and my phone is connected on 2 bars or 1 bar. It keeps on fluctuating like that. So anywho, welcome to today's session. We're going to be dealing with basic probabilities today. So by the end of the session, you should be able to know the basic concepts of probability, how to find or how to define a mutually exclusive event, a complement event, a simple event. And we're only going to end up with doing the basic probability rule. We're touching only the addition rule. And then next, on Monday, we will finish off the entire basic probability section. What is a probability? Every day of our lives, we are exposed to probabilities. If you play lotto, you are exposed to the likelihood of you winning lotto, the chances of you winning. You're playing a game of probabilities. If you are that person who's always interested in checking the weather in the morning, you are in the field of probabilities, because they tell you there is a probability or there is a chance of rainfall and so on and so forth. So probabilities are all around us. We just need to recognize them and know how they interact in our day-to-day life. So what is a probability? A probability is a study of chances. It's a study that something will happen or something might not happen. It's a chance that an uncertain event will occur, and it will always have a value, because we'll have to attach a value to it. It will always have a value between 0 and 1. And if we put it in percentages, it will be 0 and 100%. That something might happen. A certain event, it's that event that definitely is going to happen. It's an event that we are sure of that event will happen. Like, for example, the sun coming up in the morning, we are definitely sure that it's going to be coming up. So that the chance of a sun coming up will always have a probability of 1. The sun setting down or going down, it always will also have a probability of 1, because we are certain that when the sun comes up, it has to go down. There is also what we call an impossible event. That is an event that can never happen. An event that has no chance of happening. And that will always have a probability, because we said the probability has a value. It will have a probability of 0. Now, when we deal with probabilities, sometimes we also need to make sure that we assess the environment where we're collecting that, or where we're calculating those probabilities, or we're recognizing those probabilities. So there are 3 approaches that we can use to assess the probability of an event. The first one is a priori, which refers to the chance or the likelihood of an event occurring when the finite amount of outcomes, and each of those outcomes have a likelihood of happening or occurring. And that is the probability that we always use on a most in terms of day-to-day life. That is the probability, because it relies on the prior knowledge that that thing has been happening, and we are able to calculate that probability based on that, because we know that the chance of that thing happening and the outcomes, we are definitely sure that they will happen. And that probability, and this will be the formula that we're going to be using consistently as well. It's given by the probability of an occurrence will be given by the number satisfying that occurrence or that event of occurrence divided by the total number of outcomes. And we're going to get into how we define each one of them at a later stage so that it makes it easier. or clearer. The other type of way that we can assess the probability is using an empirical probability, which also, this is also one of those that you can base it on historical data that happened before. And to calculate that probability, we know that the event happened, and we can just say the number of events satisfying that event in the history divided by the total outcomes that were there. The last one, or both of these two, the priori and empirical probability, all of them assume that all outcomes are equally likely to happen. And these are also definition of what we call a classic probability. So both of them are classic probabilities. And in your module, you are always going to work with classic probabilities as well. The third way of assessing the probability is what we call a selective probability. And this is based on the researcher's opinion or subjectivity. This is based on your individual past experience and personal opinion, and also an analysis of a particular situation. And this, you cannot assume that everybody else will arrive at the same conclusion, because it's based on your own individual preference as well. And this is mostly used in psychological researches and all those other empirical researches that, or other research that usually deals with what the researcher's opinion is, and they reflect on that. Okay, so in order for us to introduce this concept of probabilities, we are going to carry on with our example of the sample survey data that we have, that we've been working on, so that it makes sense, and see how all of these things are interconnected and they can be used for decision making. So we're going to only concentrate on two columns on here. We're going to look at module code and gender going forward. We're not going to look at the rate or the age. We can use them, but for now, I'm just going to use those two columns, module code and gender, which are categorical data. Usually, for your probabilities, you will have two categorical data that you want to look at the chances or the likelihood of things happening from those two perspectives. Okay, so before we start with everything, we need to define some terminologies within probabilities. So the first thing that we need to define is what happens. So how do we get to a probability? There is a certain event that needs to happen, or there is an event that needs to happen. What is an event? An event is a process where some of the outcomes can be derived, right? So an event will be a process where you are able to generate outcomes from a variable. For example, gender is a variable. The outcome from the gender, if we only relying on two gender-specific answers, it will be female and male. Those will be the outcome. The process of creating an event will be choosing either a female or a male. Then I'm creating an event. So through that process of creating an event, of randomly choosing something, I'm creating an event. Out of that event, there will be an outcome. An outcome might be I will pick a female or I will pick a male. When I pick a female, I'm picking from one of the outcomes that can be happening or that I am choosing from that event. Okay, so that is an event. From an event, there can be different types of events that happen. So at the moment, I was referring to a gender from one variable. And that one variable create one event, and that one event, we call it a simple event. It describes a single characteristic or a single variable. Remember, a variable is we refer to a variable as characteristics that defines a certain attribute from an item, right? So a simple event will also be an event that describe or that is being described by a single characteristic or a single variable. For example, gender is a simple event. Or all students registered in STA1610 might be my simple event because I'm already also assuming of the function of an outcome 1610 from the module as well. We also have what we call a joint event. Joint event are events that happens at the same time. So for example, a student being in statistics and also being a female, both from two variables, variable gender and variable module. I have the count outcome, STA1610, and I have an outcome female. Both of them happening at the same time because I've randomly selected a student who is a female who is doing 1610. So that is me creating what we call a joint event. Two events happening at the same time, or two or more characteristics of those events happening at the same time. We also have what we call a complement event. And a complement event is an event that is not included in the original event. So for example, if I use an example of simple event, female, a complement of a female would be a male, because males are not included in the previous one, which are the females. So a complement event is the opposite of the other. They complement one another. And a complement event, they all make up what we call a sample space. They are all part of the variable. And we're gonna discuss what I mean by a sample space and the variable. So we know we have a simple event, female. We have a joint event, STA1610 female. We have a complement of a female, which is a male. We're going to be able to calculate the probability of each and every one of them so that you are able to know how to derive each and every one of them. Okay. So I also spoke about a collection of all the things, right? A sample space to say a complement of a female is a male. They all make up all outcomes of a variable or of an event. What we call all those collection of outcomes. A collection of all outcomes and all possible events. We can call them all possible events or all possible outcomes. The collection of all of them are what we call a sample space. And let's say, for example, a collection of module students who responded to this survey and they responded to a question module code. All the options underneath the module code, they are all collectively are called sample space. Under gender, all the outcomes under gender variable are all called sample space. So it's a collection of all elements of possible events or possible outcomes within that event. So how do we then visualize events? We can visualize events in many different ways. We already know that we have joint events, simple event, and complement events. We can visualize them. So let's see. We can visualize the same data set that we have of the survey data by creating a sample space. So a sample space will be all the respondents, everybody who responded to that questionnaire, regardless of what variable they responded to. But at this moment, all collectively, they create a sample space, all respondents. Of those respondents, there are people who are doing STA1610. So we know that there are people who are only doing 1610 Those who are doing 1610, they are represented by this, only that blab. But there are also students who are not doing STA 1610, so they are inside the sample space. They are included in the white space. So if there were 13 students, I hope my pen can write. If there were 13 students on that data set that are doing STA 1610, we know that our sample space had 20 values from the exercises that we did previously. We know that they had 13 values. So therefore it means the complement, so I'm gonna call it STA 1610 complement. Oh, the other thing I forgot to mention when we deal with complements, let's go back there. With complement events, we can denote them by using a copy or AC and a superscript value that refers to a complement. So that's why I'm writing STA 1610 complement, and those will be 20 minus 13, there are only 7 of them. So those are the complement. So a complement of 1610 will be all the others, which means this one will just be all QMI because that data set has QMI 1500 and STA 1510 students. So there were 3 type of modules that are on there. So those will be the complements. And that's how you will represent some of the events. Okay, so this is what we call a simple event. If I bring in another event, let's say females, we can see that the females now, we no longer have 13 here because we know that 1610 students, some of them, they only do 1610 and they do other modules, but those that are doing 1610 and are females, and we can also calculate them, all this part should make up 13. So let's call this B and let's call this A. So A plus B should make 13. And those 15, if the females, there were 18 females in total, 18 plus B should make 20, things like that. But I know that they were not they were not 18, probably there were 15 females. So C plus B, so let's say A plus B will make up 15. We said was 18, and B plus C will make 15. Therefore, it means at the middle here, which are your joint, we call those ones joint events, because those are students who are either doing STA 1610 and are female. So these ones are the others, maybe probably males. These ones are those that are only doing 1610 and they are females. On the other side, if we look at the orange side, we say all females that are also doing 1610, they are represented by the blue area. So these ones will be all the other females that are not included in that red area. So those are joint events. So we have got simple event and simple event. And when we bring both of them together and find common values between the two of them, they create what we call a joint event. And that is the area in the middle where they share that part. So when we add A plus B plus C, we should be getting 20, but we will get more. We just need to make sure that we don't double count that area twice because it falls in both sides. Okay. The other way of visualizing the event, we can use what we call a decision tree. I'm not going to go too much into a decision tree, but we can also do a contingency table. And in this module, 1510 and 1610, you might also get acquainted with this because they like using contingency table in questions in the exam assignment. But also you need to be able to read the probabilities and create the information you get from the statement into a contingency table, because it's easy to use a contingency table to answer probability questions. And you will see when we do some activities. So I took that data set that we have, I did a cross tabulation of gender and module, and I counted how many students female students are doing 1610. There were 7. How many are doing 1510? There were 2. How many are doing QMI? There were 6. And I added all of them to give me 15. And I also looked at those that are doing STA10. How many are female? There were 7. How many there are male? There were 1. And I added the total, which is 8. If I add all the totals, should give me 20. And if I add all the total from the column side, it should also give me 20. So I know that there were 20 data values in that data set. And from here, I can answer any question relating to probabilities. Now let's go and see how we calculate these probabilities. So the first probability that we're going to look at, before we look at the simple probabilities, I want us to look at the complement event, because I think we didn't touch too much on that. So let's say, for example, I need to look at the complement event of a female. So the probability of a female, or maybe before I start with that, let's do the simple probability. And then after introducing the concept of simple probability, then we can talk about the complement event. So let's do that. So a simple probability we calculate it from a simple event. And a simple event refers to that probability from a simple event. That is straightforward as that. So how we calculate it, remember, to calculate the simple event, from the priori formula, we said is number satisfying the event divided by the total outcome. The same formula, we still carry it on this. So if A is an event that is happening, to calculate a probability of that simple event A will be the number satisfying the event A divided by the grand total, or the total number of outcomes that are there. So now, if I look at gender, the probability of female, so let's say this, I need to calculate the probability of an event happening, that event, an outcome of that event becomes a female. So to calculate the probability of that event female, then I'm going to say how many number of students were females divide by the total number of outcomes of every one that is on the data set, which is my grand total, the total number of outcomes that were in the data set. So, and that is given by X divided by N. So let's look at our example. So we have the contingency table, and I need to calculate the probability of STA1610. So I want to calculate the probability of an event, STA1610. And to calculate that, the event satisfying that will be the total, regardless of what gender they are. It's all of them. So it's 8 divided by the total number of outcomes. So if I add all these outcomes that are in here, I get 20. So it will be divided by 20. Hence, it's always divided by the grand total. So the event satisfying, the number of events satisfying that event of STA1610, you get it from the total, divided by the grand total. So it's 8 divided by 20 gives you 0.4. If I need to calculate the probability of a male, regardless of that male is doing which module, all the males, there are 5. The number satisfying that event, male, is 5. The outcome is the total of all the outcomes. There are 20, so it will be 5 divided by 20, which is 0.25. I want to give you an exercise. Calculate the probability of a female. What is the probability of a female? Remember, it's the event satisfying divided by the grand total. You can write on the chat if you have the answer, or you can shout it out to save time.
0.75.
0.75, which is female, regardless of what module they are doing. There are 15 of them, divided by 20, which is 0.75. Now, I said I also want to introduce what we call a complement event. So with complement event, complement event, we said it is the other one. So if I know that the probability of male is 0.25, the probability of male complement will be equals to the probability of a female, which is 0.75. And later on, I'm going to show you the formula that you can use to do that. Okay, because we just looked at it. Male is 0.25, and the complement of a male is a female, which is 0.75. This is the easiest way, but I'm also going to show you later on how to calculate the probability of a complement using a formula. Okay, so with joint events, a joint event refers to the probability of an occurrence of 2 or more events happening. So these are joint events happening. So that is given by, so for today, you're going to learn the joint event formula. Next week, on Monday, when we deal with conditional probabilities, please remember it's different to this one, how we calculate that probability of A and B. For now, for any basic probability, where we have events, to calculate the joint event of A and B, it's given by the number satisfying that joint event divided by the total outcome, which is the grand total. So the formula is still the same, x divided by n. Looking at our data, let's calculate the probability of a male and statistics. So the probability that a student is a male and doing STA1610 is 1. So it will be 1 event satisfying that joint event divided by 20. We always divide by the grand total. And that gives you 0.05. Calculate the probability of a female and QMI 1/500. That is your question. You can shout out the answer if you have your answer, or you can type it on the chat.
Is it 0.3, Lizzie?
Correct. Which is given by 6 divided by 20, which is 0.3. That's how easy and straightforward it is to calculate probabilities. Remember, for basic probabilities. Next, we're just going to introduce what we call marginal probabilities, which are simple probabilities. So now, if you remember, with simple probability, we used the total. So with marginal probabilities, we're going to use the outcomes within the table, not just the total. So what is a marginal probability? Marginal probability are computed from simple probability equation, and how we calculate them is we just add all the joint probabilities together. The total for female 15 is made up all these joint events, right? 15 is made up of the sum of all the joint event. Marginal probabilities is the sum of all the joint events. So to calculate the probability of A, which if we calculate the probability of a female, we will calculate it using 7 plus 2 plus 6 divided by the grand total. So how do we do that? To calculate the probability of STA1610, we're going to use the conditional, the joint probabilities. So it's 7 plus 1 divide by 20. If we use the proper maths, it will be 8 divided by 20, which is equals to 0.4. Because they've got the same common denominator, 20. Calculate the female.
Lizzie, before we carry on, you said because they have the same denominator. So if they don't have the same denominator, I would say 7 divided by 20 plus 1 divided by 25 first.
So if they don't have the same common denominator, then you need to use the lowest common denominator, or you must find the common denominator for that. But for the probabilities, you will always have the same common denominator, because you always, all your probability, your simple probabilities, or your joint probabilities, you're always going to divide by the grand total, unless it's another calculation that you are doing. And your grand total will always be the same.
Okay.
So let's calculate the probability of a female using marginal probability.
That's 15.
Yeah, probability of a female will be 7 divided by 20 plus 2 divided by 20 plus 6 divided by 20, which will be 15 divided by 20, which is equals to 0.75. And that's marginal probabilities. It's the same as calculating simple probabilities. Okay. Moving on. What are mutually exclusive events? We know about simple event, joint event, and complement event. Mutually exclusive events are events that can happen at the same time. Oh, sorry. Mutually exclusive events are events that cannot happen at the same time. So they can never happen simultaneously. If I need to choose a student from a random student from the sample survey, and I say A, and event A will be a student who is in STA1610, and event B will be student who is in QMI 1500. Can both of them be at the same module? So STA1610 can never be in STA, or a module in STA. Probably I shouldn't have said student. I should have said a module. Probably choosing a module, because a student can do both. But a module that is STA, so this is not student, but a module. I will fix my slide. So a module in STA 1610 can never be a module in QMI 1510 because there are two different modules, right? So on that note, we can say an event A and B are mutually exclusive because QMI and BNU can never be happening at the same time. Can never be the same, can never occur simultaneously. Okay, the other type of an event can be what we call a collectively exhaustive event. So with collectively exhaustive event, one of the event must occur and a set of event must cover the entire sample space. So what we mean, we know our sample space is equals to 20. So all the set of events that are happening there, whether it's female, male, QMI, STA, 1610, they all need to cover the entire sample space. So if I choose a random value from the sample and A being a student in STA 1610, a student being in QMI 1500, or a student being in 1510, and D be a female or a male. If I look at this, event A, B, and C are collectively exhaustive, actually. A, B, and C are collectively exhaustive, and D and E, both on their own, they are collectively exhaustive. So B and, not B, D and E are also collectively exhaustive because all of them are happening and all of them contain the set of all the sample space. Because if I add all events from D and all events from E, I will get 20. And if I add all events from A, B, and C, which are all the modules, I will get 20. But D and E are mutually exclusive, as well as A, B, and C are also mutually exclusive because they cannot happen at the same time. Event A, B, C, D, and E are what we call also, we can refer to them as collectively exhaustive because they cover all sets of outcomes of the entire event. But they are not mutually exclusive because a female student can be in STA 1610 or can be in QMI or be in. So they are not mutually exclusive. All collectively. They are all collectively exhaustive. In a nutshell, what we have covered so far, this is what. You can use your contingency table to calculate the following probabilities. Looking at the contingency table, if this is our table, where we have event A and event B, you will find your joint probabilities and you will have your marginal probabilities by means of simple probabilities from that table. So far, in a nutshell, what have we covered? What have we said that hasn't been said and you need to know? A probability is a numerical value that measures the likelihood of an event happening. And that probability event can be any value between the value of 0 and 1 inclusively. Therefore, it means the sum of the sum of all probabilities can also just be equals to 1. The reason being, you can never have a negative value for your probability, or you can never have a value more than 1 for your probability. So your probability will always be between 0 and 1. And like I said, the sum of all probabilities will be equals to 1. So if I add the probability of A plus the probability of B plus the probability of C, all of them should give me 1. And this only and if and only A and B are mutually exclusive and collectively exhaustive. Only then. If they are not mutually exclusive and they are not collectively exhaustive, they will never make up to one. They need to be mutually exclusive and collectively exhaustive events. A complement event is defined to be the event consisting of all sample events that are not part of the A event. And we can use this formula, like I said, we will introduce a formula later on. So a probability of A can be given by 1 minus the probability of A complement, or the probability of an A complement. So if I want to find the probability of A complement, it can be given by 1 minus the probability of the event A. Similarly, we calculated the probability of male. And we said the probability of male is 0.25. And to find the probability of a male complement is 1 minus 0.25, which is equals to 0.75, which we also found that in turn is the same as the probability of a female. And that's how you can find the complement event. Moving on to the last part of our discussion for today is introducing the addition rule. An addition rule is another way of calculating the probability of A or B, the probability of calculating an event, either one of the events happening. And that is given by the probability of A or B is given by the probability of A plus the probability of B minus the probability of A and B. That is the formula that you need to always remember when you have to calculate the probability of either events happening. The other thing, the or can be the sign that can be used for or is U, which is union, and the sign that can be used for and sometimes it's intersect. So you will see that they sometimes use them interchangeably, and I will also try by all means so that you are able to remember them, to use them in our exercises sometimes. If event A and B are mutually exclusive, remember, if they are mutually exclusive, therefore it means the two events A and B can never happen at the same time, then the probability of A and B is equals to 0. This you need to always remember. For mutually exclusive events, the joint probability of those two events is always equals to 0. And in that case, the probability of A or B will just be given by the probability of A plus the probability of B. But this is only and only when the event A and event B are mutually exclusive. If they didn't say that they are mutually exclusive, then we use that formula at the top. Let's look at an example. We know the formula. We have our data. Let's find the probability of a student doing STA1610 or a female. Then it means we need to calculate the probability of STA plus the probability of female minus the joint probability of STA and female. Why? If you look at the probability of STA, it has 8. The probability of female is 15. They both have the probability of STA 1610 and the probability of female. They are both adding 7 to that. So in 15, there's 7. In 8, there's 7. So we need to reduce one of them. That's why we're subtracting 1 from there. So let's calculate the probability. So the probability of STA 1610 or female is given by 8 divided by 20, because that's how we calculate the probability, or a simple probability of STA. And the probability of female is 15 divided by 20 minus the probability of joint probability of STA 1610 and 1510, and that answer will be 0.8. I want you to calculate the probability of QMI and male. Probability of students doing either QMI 1/500 or the student is a male. And that is given by the probability of QMI. Just gonna write it in short, plus the probability of male minus the joint probability of QMI and male. Like I said, I'm gonna change it a bit. So our probability of QMI, we calculate it there, it's 7/20 plus the probability of male, it's 5/20 minus the joint probability of 1/20. So we can say, because they've got the same common denominator, we can just add the numerator. So it's 7 plus 5 minus 1 is equals to 11/20, which is divided by 20. 11 divided by 20, which is 0.55. Did you also get the same? Okay. And that concludes today's session. I had some activities, but looking at the time, and because I've got another session just now, I'm gonna give it, we're gonna do one question, one activity, and then we call it the day. And then you can do the rest of the other activities on your own. Okay, so let's look at that activity. The table below shows how many boys and girls consult with different specialists. Which one of the following statement is incorrect? And here we are given a contingency table with speech therapist, which they call it as T, neuropsychologist and P, psychiatrist P, boy and a girl. And what is missing on this table is the total. So every time you find questions like this, whether in the assignment or the exam, I will suggest that you do the total first and then answer the question. So at the speech therapist, the total will be 120. 45 plus 15 is 60. 90 plus 45. 90 plus 45 plus 30 is 165. And 165 plus 55
220.
is 220. And I can also calculate that. 220 minus 120 minus 60 gives us 40. And if that is 40, then it means that is 10. And that's how you will complete the table, and then you can then go and answer the question. So the first one, the probability of boy, X divided by N. Boy, regardless of which specialist they went to, there are 165 divided by 220. Probability of boy or a girl, remember it's given by the probability of a boy plus the probability of a girl minus the probability of a boy and a girl. Now, a boy and a girl are mutually exclusive, so this will be 0. And the probability of a boy will be 165 divided by 220. Plus, a probability of a girl will be 55 divided by 220. And you can just check if that answer is equals to 1. And you do the same with the probability of a girl and STA. So it will be the probability of a girl plus the probability of ST minus the probability of a girl and ST. Probability of, I'm gonna write it here. Probability of a girl is 55 divided by 220 plus the probability of ST regardless of what gender. It's 120 divided by 220 minus the probability of a joint girl and ST is 30 divided by 220. And you can check if the answer is there. Probability of ST, it's event satisfying divided by the grand total. ST is 120 divided by 220 because it's regardless. The probability of ST is given by, I must just put the equal sign. The probability of ST plus the probability of NP minus the probability of ST and NP. Now, NP and ST are complement events from this side. So therefore, it means that will be equals to 0. Then we are only going to calculate the probability of 90 divided by 220 plus the probability of 40. Oh, sorry, I'm using the wrong numbers. ST is 120 and NP is 60. We use the total over 220. So which one of the following statement is incorrect? So the first one, 165 divided by 220, which is 0.75, which is correct. The second one is 55 divided by 220 is 0.25 plus 0.75 is equals to 1, which means that is correct. The third one is let's say 55 plus 120 minus 30 equals 145 divided by 220 equals to 0.66. That is incorrect. The fourth one, 120 divided by 220 is 0.545, which is correct. The last one, 120 plus 60 divided by 220 equals 0.818, which is that correct. And that's how you will answer the questions. So I'm gonna give you all the other activities that you can practice. You can take a screenshot of each question as I move. So on this one, you will also have to calculate the total and try and answer the question and find which one of those statements is incorrect. second one, you can ignore this one. We will cover it next week. The third one that you can do, it's the same as what we just did. You can also ignore that one. So I'm, like always, thank you for coming and being part of the session for today to help me with the recording. Remember, we from Pambile Analytics, where we bridge the gap in terms of data literacy and analytical skills by offering skills development training. We do a range of services, but more especially in terms of skills development, we offer one-on-one consultations or instructor-led support. We're still running it on special for 150 per month. Otherwise, you can join some of the self-led online training sessions that we have. If you haven't subscribed to our channel, YouTube channel, please remember to subscribe and click on the notification button for new videos as they get uploaded. Remember also to get access to the recordings and the videos. You need to join, and please choose either one of the following membership for you to be able to access the recording. And at this point, I would like to do a shout out to two people who are our loyalists. I always don't know how to pronounce her name, but I think it's called Johannesal and Bamboo. Thank you for your support. Otherwise, there are more of you who have joined as supporters of the YouTube channel, as well as the cheerleaders of the YouTube channel. I really appreciate your contribution. Next time I will give you a shout out because there are more of you than those that are loyalists or appreciators or even promoters. Thank you very much for joining, and keep watch and enjoy the rest of your weekend. Bye.
Thank you, Lizzie.
Thank you. Take care.
Thank you, Lizzie.